A few days ago, Anthropic released a new AI model to the public. At first, that sounds normal. AI companies release new models all the time now. There is always another benchmark, another product demo, another claim that the newest system is faster, smarter, or more capable than the last one. But this launch was different, because before Anthropic was willing to put this model in front of ordinary users, they built something unusual around it. Another AI, not a simple filter, not a list of banned words, not a warning message that appears when a prompt sounds risky. A separate AI system designed to watch the model, judge what users are asking for, and decide when the most powerful version should not be allowed to answer. That detail is easy to miss, but it may be the most important part of the story. Because when an AI company needs one AI to supervise another AI, it tells us something about the moment we are entering. The technology is no longer just impressive, it is becoming difficult to control. And the question is no longer simply, how smart can these systems become? The question is, what happens when they become powerful enough that even their creators feel they need a guardrail made of AI? To understand why Anthropic made this decision, we have to go back before the public release. Before the model called Claude Fable 5, before the safety system, before the launch announcement. The story begins with another model, Claude Mythos. Mythos was not originally meant for the public. It first drew attention after a draft document surfaced online. The document appeared to describe a model with unusually strong capabilities in software analysis, cybersecurity, and advanced technical reasoning. This was not being described as a better chatbot. It was not just a tool for writing emails or summarizing documents. The concern was that Mythos could examine large code bases, identify weaknesses, and find vulnerabilities that human engineers had missed. In cybersecurity, that is a breakthrough, but it is also a problem, because the same ability that helps defenders protect systems can also help attackers break them. That is the uncomfortable truth behind many advanced AI tools. Their value and their danger often come from the same capability. If a system can find a serious vulnerability before criminals do, it can make the internet safer. But if the wrong person uses that same system to find weaknesses in real targets, the risk changes completely. Anthropic seemed to recognize this early. So, instead of releasing Mythos to everyone, the company restricted it. They created Project Glasswing and gave access only to selected partners. These were organizations involved in defending important digital infrastructure, major technology companies, cybersecurity firms, cloud providers, and groups connected to open-source software. The goal was clear: use the model to find dangerous security flaws before attackers could exploit them. And once the project began, the results were hard to ignore. The AI was used to examine more than 1,000 open-source projects. That matters because open-source software quietly supports much of the modern internet. It runs inside servers, browsers, cloud systems, security tools, video applications, and countless services people use every day without thinking about them. Then the discoveries began. Thousands of bugs. Hundreds of serious vulnerabilities. Some were high severity. Some were critical. Some had been sitting inside widely used software for years. A few had reportedly existed for more than a decade. One example involved a vulnerability in OpenST that had been present for 27 years. Another involved FempEG, a tool used across a huge part of the video software ecosystem. That is the kind of detail that changes how people think about AI. For years, engineers maintained that software. Experts reviewed it. Companies depended on it. And still, those flaws remained hidden. Then an AI system found them in weeks. On the surface, that sounds like a major victory, and in many ways, it is. A model like this could help strengthen the internet. It could help security teams discover hidden weaknesses faster. It could give defenders a better chance against criminals, ransomware groups, and state-backed hackers. But there was another problem. The AI was finding vulnerabilities faster than humans could fix them. That is the part that should worry people. Finding the flaw is only the first step. After that, someone has to understand it, verify it, write a patch, test the patch, release it, and make sure the fix does not break something else. That work still depends on human teams, and many open-source projects are maintained by small groups, sometimes even by volunteers. So, when an AI suddenly discovers thousands of issues, it does not automatically make the world safer. It can also create a backlog of danger. In the past, the hard part was often finding the vulnerability. Now the hard part may be fixing everything fast enough. That is a new kind of imbalance. And it helps explain why Anthropic treated Mythos so carefully. But after months of limited access, the company decided to release a public version of this technology. That model was Claude Fable 5. Fable 5 was presented as a powerful public model, but not the same as giving everyone unrestricted access to the underlying system. Anthropic wrapped it in a safety architecture designed to monitor how it is being used. This is where the second AI comes in. Anthropic built safety classifiers around the model. These classifiers watch user requests and look for signs that someone may be moving into high-risk territory. The key areas are cybersecurity, biology, chemistry, and model distillation. Cybersecurity is the most obvious concern. If a model can help find vulnerabilities, it might also help someone plan an attack. Biology is more complicated. Advanced AI could help researchers design treatments, improve drug discovery, or solve difficult scientific problems. But the same reasoning ability could also be misused for harmful biological research. Chemistry has similar risks, especially when a model can reason about dangerous compounds or restricted processes, and then there is distillation. Most people outside the AI industry do not talk about this much, but it matters. Distillation is when someone tries to use a powerful model to train another model, copying part of its capability into a separate system. In simple terms, it is a way of extracting intelligence. If someone could copy the power of a frontier model without copying its safety controls, they could create a dangerous tool outside the original company's oversight. That is why Anthropic appears to treat this as a serious threat. When the safety system detects a risky request, the user may not get the full model. Instead, the request can be routed to a less capable system. That is a very different approach from traditional moderation. It is not just saying yes or no. It is deciding how much intelligence the user should be allowed to access. That may become one of the defining features of future AI products. As models become more capable, safety may not be handled by simple refusal messages. It may depend on access levels, monitoring systems, risk scoring, and automated decisions about which model can respond. That raises hard questions. Who decides what is too dangerous? How transparent should companies be when they reduce model capability? Should users always know when they are being routed away from the strongest system? How much monitoring is acceptable? And if the most powerful AI systems require constant supervision, what does that say about the direction of the industry? These questions become even more serious when we look beyond cybersecurity. One of the most sensitive parts of this story involves biology. According to the script, Mythos was tested on a difficult problem related to adeno-associated viruses, which are used in legitimate gene therapy research. The model reportedly performed extremely well, even compared with specialized tools. If true, that is an important signal. It suggests a general-purpose AI may be able to reason through complex biological problems without being built only for biology. For medicine, that could be extraordinary. It could help researchers move faster. It could support drug discovery. It could improve the design of therapies. It could help scientists explore problems that are too complex for older methods. But the same capability also creates fear, because biology is not like writing a poem or generating a spreadsheet. If a system can reason deeply about biological design, then people will ask whether it could also be used in dangerous ways. That is the dual-use problem. The same tool can heal or harm. The same system can defend or attack. The same intelligence can accelerate science or accelerate misuse. And this is why the Anthropic story is not just a product launch. It is a warning about the next phase of AI. The timing also matters. This is happening during a period of intense competition between major AI companies. Anthropic, OpenAI, xAI, and others are all racing to prove that their models are the most capable. There is enormous money behind this race. Investors want growth. Companies want dominance. Customers want better tools. Governments want strategic advantage. And inside that environment, every new model becomes more than a technical release. It becomes a signal to the market. Who is ahead? Who has the best technology? Who can attract the most enterprise customers? Who can justify the highest valuation? That financial pressure changes the entire safety conversation. A company can believe a model is risky and still feel pressure to release it. Researchers can warn that things are moving too fast, while business teams know competitors are moving just as quickly. Safety teams can ask for caution, while the market rewards speed. This is the tension at the center of the AI industry. And Anthropic's position is especially complicated. On one side, the company presents itself as safety-focused. It openly talks about risks, misuse, and the need for careful deployment. On the other side, it is still releasing more powerful systems. That may look contradictory, but there is a logic behind it. The argument is that responsible companies should not simply stop. If they slow down too much, less cautious actors may take the lead. In other words, the safest path may be for companies with stronger safety cultures to stay ahead. That is the bet, but it is not a comfortable bet. Because it means the answer to dangerous AI is not necessarily less AI. It may be more AI, surrounded by more monitoring, more safeguards, and more control systems. Maybe that is the realistic path. Maybe it is a dangerous rationalization. But either way, this is the direction the industry appears to be moving, and it leads to another issue: privacy. For very powerful models, companies may increasingly argue that they need to retain data for safety monitoring. They will say they need to detect abuse, jailbreaks, coordinated misuse, and new attack patterns. From a safety perspective, that argument makes sense. If a model can be used dangerously, the company needs visibility into how people are trying to misuse it. But from a user perspective, it changes the relationship with AI providers. The more powerful the model, the more likely it becomes that access will come with monitoring. Not because the company wants to train on everything, but because the company wants to see what is happening at the edge of misuse. That may become the new trade-off. More capability, less privacy, more power, more supervision, more intelligence, more control, and that brings us to the bigger picture. We are entering a period where AI may be advancing faster than many institutions can adapt, faster than software teams can patch vulnerabilities, faster than regulators can write rules, faster than companies can build governance systems, faster than ordinary users can understand what these systems can really do. That does not mean every AI release is dangerous. It does not mean the technology should be rejected. The benefits are real. AI could make software safer. It could help scientists work faster. It could give doctors and researchers better tools. It could improve productivity across entire industries. It could help defenders respond to cyber threats at a scale humans cannot manage alone. But the risks are also becoming real. They are no longer just theoretical debates in research papers. They are showing up in product design, in model access, in safety systems, in data policies, in government discussions, in infrastructure security, and in the decisions companies make before releasing their most powerful tools. That is why this moment matters, not because one company launched one model, but because this may be a preview of how future AI will work. The strongest systems may not simply be released. They may be guarded, monitored, limited, rerouted, and controlled by other AI systems. That is a major shift, we are used to thinking of software as something people operate. But frontier AI becomes something people negotiate with through layers of automated control. The model answers, another model watches. A classifier judges risk, a safety system decides how much capability should be available. That is not the old internet, that is not the old software industry. It is a new kind of infrastructure, and the central question is whether our ability to control these systems can keep up with our ability to build them. Anthropic's bet is clear. They believe powerful AI should be developed carefully by companies that take safety seriously, because the alternative is letting less careful actors get there first. But not everyone will agree. Some people will say that is the only realistic approach. Others will say it is exactly how arms races become impossible to stop. And that is the question this story leaves us with. If an AI becomes powerful enough that it needs another AI watching over it, should we see that as responsible safety engineering? Or as a sign that the technology is moving too fast? The answer may shape not just one company's future. It may shape the next stage of artificial intelligence itself.